All right, this video is a lesson about how to deal with system of equation word problems. And the key to doing that is to identify the two things that are going to be represented by the variables and to create two equations that you can, or inequalities that you can use to do your solution. Let's look at this problem as an example of how to find the two things that are going to be represented by the variables and how to make the two equations. In 1998, the sum of the number of $2 bills in circulation and the number of $50 bills in circulation was 1,500,888,647. The number of $50 bills was 366,593,903 more than the number of $2 bills. So our first question there is to write a system of equations to represent this situation. Then we'll find the amount of money that was in circulation in $2 and $50 bills. Right. The two things we're talking about here are $2 bills and $50 bills. So we can let our two variables represent those things. So if we let X be the number of $2 bills and Y be the number of $50 bills, now we can apply the information that was stated in the problem. It tells us that in 1998, the sum of the number of $2 bills in circulation and the number of $50 bills in circulation was the 1,500,000,000 number. So that means the sum of the $2 and $50 bills was the 1,500,888,647. Let's write that as an equation, right? The sum means we're going to add, and the number of $2 bills and $50 bills is represented by X and Y. So X plus Y equals 1,500,888,647. What else does it tell us? The number of $50 bills was 366 million more than the number of $2 bills. So the number of $50 bills was 366 million. I'll abbreviate that a little bit. More than the number of $2 bills. All right, so Y equals X plus 366,593,903. So there we have our two equations. X plus Y equals the 1,500,000,000. Y equals X plus 366,593,903. Okay. We have our choice of how to solve this. It looks like it's set up pretty well for substitution since it's already solved for one variable, but you could use any method you want. Yeah. By substitution, we want to take our our equation for Y and substitute it in the middle of the equation for X. So we would have X plus whatever that expression was for Y, and it's going to equal 1,500,888,647. What was that expression for Y? It was X plus 366,593,903. Numbers are a little big, but the ideas still hold. All right, for substitution, we solved, or we're given one of the equations already solved for one variable. We're plugging it into the other equation. Now let's solve this. Combining like terms, we'll have 2x plus 366 million equals the 1,500,000,000. Subtract the 366 million from both sides. And let's see what we get. We get 2x equals, let's write these digits down here and get the commas. 1, 1, 3, 4, 2, 9, 4, 7, 4, 4. So that is 1,134,294,744. And we're going to have to divide both sides by 2 to find out that x equals, get our digits, 5, 6, 7, 1, 4, 7, 3, 7, 2. So that is 567,147,362. So that's how many $2 bills we're dealing with. As always, we've got to plug that number back into our expression for y. So we have y equals x, 567,147,372 plus 366,593,903. And that turns out to be, our digits are 933,741,275. So that is 933,741,265. That's how many $50 bills there are. So that takes care of question 9 and question 10. Now, number 11, find the amount of money that was in circulation. The amount of money. 2 times x plus 50 times y, right? $2 for every $2 bill, $50 for every $50 bill. So 2 times that 567 million. Let's abbreviate a little bit here. Plus 50 times 933 million. And let's see what those actual numbers turn out to be. All right. So it actually turns out to get the same amount of money for both $2 bills and $50 bills. So that brings our total to, looks like 3,734,965,100.